This is going to be a short introduction or a recap for some of you on how to write chemical names and chemical formulas. I have 3 examples here typed out, but I am going to be going into more detail explaining why these names are associated with the formulas, so we kind of get a look at both sides of it. I have explained in another video before that a lot of the time, this is how you're going to see chemical formulas written. We're going to see the names of them. We're not going to see the symbols and the subscripts as much. And the reason being is this is way easier to type out. It's just more common. It's just what we see. It's easier for teachers to type out. It's easier for exams, tests, midterms, finals. It's easier for scientists. It's just easier whenever we're typing or using a computer than selecting all those subscripts and manually putting all those in. And it's understood in the scientific community that we're able to take these and write the chemical formulas of them. So check out my first video for dimensional analysis with one compound, and you'll see why it's important to get the formulas right, because we'll actually be needing to calculate with the grams from the periodic table. So the first example we're going to do here is iron 2 phosphate, and I also have iron 3 phosphate. So I like doing those 2 examples together because having this stock number as the difference to see, you know, what's up, what's the deal with that? I like being able to compare and contrast the difference so it's easy to understand what these are for. A lot of people forget what they're for. It's called the stock number, and the stock number indicates to us what the charge is. So the charge of this iron is going to be positive 2, and the charge of this iron is going to be positive 3. We don't need that for other metals. So notice how down here I don't have the stock numbers written because of the location of where these are on the periodic table. We can use the pattern with the S block and the P block to determine what the charge is and what the charge always will be. Whereas transition metals, those are the special ones. For transition metals, we need a stock number. And we need a stock number with transition metals, especially because we could have the same metal with multiple charges. So it's important to know that. It's important to know all the symbols and what they are. So iron is Fe. Iron is Fe, and I'm going to change my color here, get a couple of different colors going. And then phosphate, we do need to know that phosphate has a 3 minus charge, and it's PO4. Phosphate has a 3 minus charge, and it's PO4. Now for my students, they're allowed to use a chart of common polyatomic ions that tells us the formula and the charge. So my students do not have to memorize these. A lot of students do. So keep that in mind, that these are just things you need to know. And this is given to you. So this 2 right here indicates that the charge is 2, and this 3 right here indicates that the charge is 3. So that's nice that that's given to you because it's not given to us in the other problems. So what I like to do is I like to first take a good look at my whole situation, my whole problem, and I like to write the formulas, and I like to leave a little bit of space. But what I'm going to look at here is I have to figure out how many of each of these do I need in order to make these charges cancel out, because that's the goal. They need to cancel out. One thing I've taught my students is it's kind of like finding the common denominator of 2 fractions. If you have 2 fractions where the denominator is 2 and 3, the common denominator is 6. So in order to make this a 6, I would have to multiply this by 3. In order to make this 6, I'd have to multiply this by 2. That's a very advanced way of looking at it, but I like to just say crisscross applesauce. So the 3 comes down here, the 2 goes down here. When you change the location, it changes the meaning of the number. So a superscript, something that looks like an exponent that goes further up with the charge, that tells us the charge, positive or negative, and how strong the charge is. But once we move that number to the bottom, so we have Fe3, that tells me I need 3 irons. And then for phosphate, I'm going to need 2 phosphates. So PO4. And I'm going to bring my 2 down. So I'm actually going to fix this right here because I like to color code. So everything that's in orange is going to go with the iron, and then everything that's in purple is going to go with the phosphate, so PO4. So that's my final answer. This is what iron 2 phosphate looks like. So let's take another look at this, shall we? I crisscrossed my charges because of what our original charges are. So now this technically has a 6+ charge, and this whole thing has a 6- charge. We have to put parentheses because we have to show that we need 2 of these. I need 2 phosphates, and this whole thing is phosphate. Once you change that, it's no longer phosphate anymore, and it's no longer right. So I crisscrossed those numbers, so this 2 goes up here, or used to go up here with the iron because it has iron 2. That's what we're given. And this 3 was the charge of phosphate. But now that we've switched and crisscrossed, we have 1 solid compound, which is really nice. Now the next example is a little bit easier because in the first example we had 2 different number charges, but here we have the same number charges. So it's kind of like a fraction. You don't necessarily want to find a common denominator or crisscross because they're the same. You can just simplify. We need simplest terms. I'm sure you guys remember hearing that in 9th grade or even younger. So these cancel out, and you literally just write the whole thing together. It is now iron phosphate with no additional subscripts. But then the question that I get all the time whenever students are given the chemical formula is, how do I know this is iron 3? How do I know that it's not iron 2? How do I remember to put a stock number? So there's a few answers to that question, or to those questions. So first of all, you put a stock number because iron is a transition metal. All transition metals need stock numbers. You can't go without them because who knows what the charge is? You're absolutely right about that. We don't know. So the second answer that I would say is, look at your phosphate over here. We know this is phosphate. What's the charge of phosphate? Well, phosphate always has a charge of 3-. And I don't see any 3s down here. There was no crisscrossing. So the question is, if this is 3-, what does this need to be in order to cancel out perfectly with no extra subscripts? So the answer would be, well, it's got to be a 3+ if that's a 3-, so it cancels each other out. For this one up here, a lot of students will see this 3 and they'll think it's iron 3, but it's not because you crisscrossed your charges. So because we have this 2 here, this subscript of 2, this is iron 2 because that 2 used to belong with the iron before it was crisscrossed. Here, not so much. So this problem is a little bit different. This one varies, and I'm going to kind of section this off so it's easy for you to see what all is different about it. So the thing that really does stick out to me as being different are these charges right here for iron 2 and iron 3. So that's the only difference between these two problems. That was my attempt at a highlighter. That didn't look too great, did it? But you get the point. So looking at the next 2 problems, and I'm going to try to use a nice little variety of colors here so that it's easier to keep up with. We have magnesium phosphate. So again, it's easier for you to show your work. Here I showed my work, but the goal, the point is for you to eventually get to the point where you're not showing any work at all. So for magnesium phosphate, magnesium is Mg. It has a charge of +2, and I know this by looking at the periodic table. It's in group 2 of the periodic table, and everything in group 2 has a +2 charge. Phosphate, well, we already have seen phosphate in the previous 2 problems. We know it's PO4 with a 3- charge. I think I was going to actually change this to phosphite just for a little bit of variety because I changed this one down here. The only difference between phosphate and phosphite is PO3, but you still have the charge, so it really doesn't matter. So magnesium phosphate is just fine. We're going to just go with it, and it's going to be the same thing before. We're going to crisscross those charges. So we're going to bring this 3 with the magnesium, and we're going to bring the 2 down with the phosphate. So I'm not color coordinating this one as much because hopefully as we do more examples, you get a better hang of it. So we have Mg3, and then I need 2 phosphates. And because I need 2 of these and it's one big group, I'm going to have to put in parentheses. So PO4, 2. And again, I want you to notice the difference between where the numbers are located and what they mean. When these numbers are up high, we have charges, positive and negative, assigned to them. These are just the charges. When we bring them down low, it now indicates how many of each atom or molecule we have in the entire molecule. So same deal with gallium-3. Gallium is in group 13. It's in the P block of the periodic table, and it has a 3+ charge. It'll always have a 3+ charge. It is not a transition metal, so we do not use stock numbers for gallium. So iron is a transition metal. We have to use these stock numbers. Here, there's no stock number because gallium always has a positive 3 charge. Phosphide, when it ends in IDE, it's just phosphorus. No oxygens, no polyatomic, nothing. And phosphide, if you look at that group, that is group 13, 14, 15 on the periodic table, that's in the nitrogen group, they always have a 3- charge. And we have something really magical happening here. The same thing that happened here, 3 plus 3 minus, they just cancel each other out. And what do you know? We have a 3 plus 3 minus, they cancel each other out. So our final answer is quite literally GAP. GAP, gallium phosphide. So we're not going to go in as much detail in other videos moving forward about how to write the chemical names, but if you do look at the 2 videos I have up with dimensional analysis using one compound, I have a very brief explanation, not as in-depth, but a very brief explanation of how you put them together. And again, it is important because coming soon, if you haven't already, you're going to need to know how to calculate the molar masses of each one of these.